So we're talking about conditional. And we've actually seen some stuff like this in a way. I haven't really identified it as conditional probability. Okay. Now I want to explain to you what this notation here means. So circle this, draw an arrow down here. Wait, what? So I can explain what this means. Probability of A, and then with that vertical bar. Not quite, no. What this means written out is the probability of A given, that's what this line right here means, this vertical bar means given. So what's the probability of A given that B has already occurred? Given that B has already occurred. That's how you would read that probability out loud.
Technically, you interrupted my pastime, but I interrupted your pastime as well. So, it's a win-win.
How do we draw between pastimes?
You just did.
Yep. So, there will be some time that we're going to have to use this formula a little bit later, but I'm going to show you on today's problem that we can figure out conditional probabilities without having to use that formula. Okay? So turn the page. So we have this example right here with this bakery selling cupcakes, it looks like.
It says chocolate chip.
So these first two are just regular, either simple or compound probabilities. We're going to get to a conditional one down here in a second. But let's just quickly do these so we can remember how to figure out a probability in a table. You have to know the size of the sample space to figure out our probability. So on this table, 21. There were 21 total cupcakes. You find that right here. So what's the chance that you get a chocolate cupcake with white icing? If you just are given a cupcake at random, white icing, chocolate cupcake, what's the chance that happens? How many of the chocolate have white icing? 6. Out of how many? 21. So the chance to get a chocolate cupcake with white icing is 6 out of 21. You have to use the entire sample space. If it doesn't matter what kind of icing, whether it's blue or white, what's the chance that you just get a vanilla cupcake? Doesn't matter the icing. There's 3 here and 5 here, so total there's 8 vanilla cupcakes out of 21. So the chance that you get a vanilla cupcake is 8 out of 21. Now these are not conditional probabilities. These are things that we've done before. We're just refreshing a little bit. I want you to write this down underneath this little paragraph. What's the probability that you get blue icing given chocolate has already been chosen? Now, why does chocolate have to be chosen? If you read through this, Alex's favorite cupcake is chocolate, blue icing. What's the probability he will get his favorite cupcake if all the vanilla cupcakes have already been sold? All of the vanilla cupcakes are gone. So that's why we have to have this condition. Do you guys understand? If all the vanilla cupcakes are gone, what's the chance he gets blue given that his cupcake has to be chocolate? Do you understand why the condition is there? The level's gone. Now, here's what happens when you do a conditional probability. Are we going to use the entire sample space anymore? Just the chocolate, because it's been given that he will get a chocolate cupcake. So the sample space is no longer 21. What's the sample space? 13. That's it's out of 13. So out of the 13 chocolate then, it's going to be 7 out of 13. Now I need you guys to stop writing for just a second and listen. Because this will be the case most of the time. A condition shrinks the size of your sample space. Did you hear that? Yes. The condition determines the size of your sample space. Instead of using 21, we use the given condition sample space of 13. And then you just figure out the probability like normal. Alright? It'd be 7 out of 13. Let's go to this Venn diagram. Yeah. All these guys have cool nicknames like Miss K. I want a cool nickname. That's not a cool nickname.
It's hard to say.
For you guys, how much I was teased growing up with that? You know? How about Max Power?
How about Ball? Power?
It's from The Simpsons.
What about Shiny Head?
Wait, I got a good one. We could call you Mr. Buff.
Mr.
How about Swim Star?
Swim Star, there you go.
We'll call you SS.
No, I got it. From now on, you will address me as Mr. Speedo. Yeah, that's what I will not answer to anything but Mr. Speedo.
I'm going to call you Tough Buff.
Top them up, yeah.
Okay. These three right here are just normal probabilities. They're not based on a condition. So, use the Venn diagram. Figure out the sample space. How big is Miss K's class? How many students are there in Miss K's class?
35.
I'm hearing a bunch of different numbers.
35.
I've heard some of you now say the correct number. It is 35. Yes, these students are still in the class. They just don't have an iPod or a cell phone, but they're still in there.
They're just the users of the
Guys, these are actually students whose parents care about their education and don't buy them a dang cell phone.
Actually, but they're going to happen if they trip and break their ankle on the way home from school. Then what? They're going to lay there and suffer.
They'll use somebody else's cell phone.
What if they only had a cell phone?
Yeah, what if they city center and they got
If their parents care enough about them to not get them a cell phone, they'll come pick them up after school.
Okay, I go to the mountains every day. What if I roll my finger?
You know, those 6 people probably
We'll get service up there anyway.
I've got service everywhere I go.
Anyway,
those 6 people are doomed to die.
what's the chance that if somebody from Mrs. King's class is chosen at random to have a cell phone? What's the chance of somebody from Mrs. King's class is chosen? Where's 25 coming from? These people have cell phones.
Actually, it's 5 out of 7.
Okay? Those people have cell phones. There's 25 of them. 25 out of how many? 25 out of 35 would round down to
5 out of 7.
5/7.
Oh, I hate that word.
Both of these groups have cell phones. These just have a cell phone plus an iPod, but they still have cell phones. Now, what's the chance that you choose somebody that has either a cell phone or an iPod? Doesn't matter which one, but they have one or the other.
Yeah.
What do you think?
29 over 30.
You're saying 29 out of 35?
Yes, because there's all of them and there's 35 kids total.
15 plus 4 minus
15 plus 1 minus 10.
Let's go back to the very first lesson we did. Or means the same thing, not that. Or means the same thing as union, right?
No.
The union would be everything in there. So it's 29. Or you can think about it this way. If you want to choose somebody that has a cell phone or an iPod, then just don't count the students that have neither. If you don't count the 6 that don't have any of them, then how many are left? 29. 29 out of students have either a cell phone or an iPod. So it's 29 out of 35, which does not reduce. 29 is prime. All right, here's the tricky one. Well, this one's actually easier, I think, than number 2. How many of them have both a cell phone and an iPod? That's the intersection right here. 10 out of
2 out of
35, which is 2/7. I want you guys to cross out this. This really wasn't much good.
Yeah, it doesn't make much sense either. Presumably you can't have an iPod.
No. I don't want you guys to ever try.
But why just,
Okay, no, we are not going to do that. What's wrong with Speedo? Why are you guys so afraid of Speedos?
Because it makes me feel like I'm having experience with being a speedo, which I'm not, and I do not want to imagine.
So, the given condition.
Sounds like a nickname experience, but there has been no experience.
I'm asking a different question than this right
Of course
here.
you will.
We can tell
Okay.
by Blair.
What's the chance that someone with an iPod is chosen given, that's what this vertical bar means, given that that person already has a cell phone? Now, remember what I said a few moments ago. The condition sets the sample space. So we're no longer choosing out of the entire class.
We're not just choosing an island. So
We're choosing from this condition right here. So let's first figure out the sample space. The sample space are those students who only have cell phones. That's the sample space. Because that's what the condition says. You guys follow? Now, of this sample space, how many of them have iPods? 10. 10 out of 25. The condition sets the sample space. 10 out of 25
2 out of 5.
is 2 out of 5.
Is this open?
This is pretty much what the assignment is.
Yes.
Okay? You have to figure out the condition, and then using that condition, you've got to figure out your sample space,
So the
and then.
given is pretty much that.
Yep.
I'm so confused. So like on the last one, why I'm still gonna get my minus 10, not like 14.
These 4 only have an iPod. They don't also have a cell phone. This condition says who has an iPod given that they also have a cell phone.
But now the iPods can be used as cell phones, so therefore this logic is blind.
So keep this page open that you have because I want to reference it for,
The future.
well, to help us on this assignment.
So for the future.
I guess.
So, the not so distant future. So it's from
Yes, these are pretty simple once you understand how to use the condition. So let's take a look at this front page. You have this table on the front page, I believe, right?
No.
This box usually represents the sample space you're going to use if you're doing a normal probability. There's 797 people that were surveyed. But question 1, what's the chance you choose somebody who walks home from school? I think that's what they're talking about. Who drives a bus home, who rides in a car, or who walks. What's the chance you choose somebody that walks given that that person has to be a female? We're choosing out of only 403 students now because they have to be female. And of those 403, what'd you guys say? 64. You see how easy these are to calculate? In my, let's see, 403. That's prime, I believe. I don't think that's simplified.
Can you help with number 5 and 6?
More girls go to school.
Oh, and that doesn't really do. Let's just get to number 5 and 6.
They tried to survey more guys, but they were down to the 7-Eleven during school hours.
7-Eleven, you get that, you just go home. I didn't know that.
Well, number 5 and 6.
Question 2. What's the chance you choose a guy given that they drive home in their own car?
166.
You guys listen, the private car is the denominator. So how many students, whether they're male or female, how many students drive home in a private car? So that's our denominator. Now of those 351, how many guys? 166. Now some of these may or may not simplify. I'm just writing down the initial fraction. You guys are going to have to figure out if they'll simplify or not. So quickly do 1 through 4 and then stop because I'm going to help you on 5 and 6. So just take a moment to do questions 1 through 4.
I have a question. On number 72.
What did you guys get for 3?
I got it. I think this is wrong, but it's 304 over 146.
It's actually 73 over 187 is doing something else.
It's
146.
Jeff, question. This is always what comes after this sense. So on question 3, what's the probability that somebody rides the bus given that they are male? So they have to be male. So that means out of 394. So out of 394, how many of them would ride the bus? 146. Now that simplifies because they're both even. So start getting comfortable, you guys, using your calculator. This one isn't actually that bad to do by hand, but type in 146 divided by 394. Use the fraction feature of your calculator, and it's 73 out of 197. Okay, yours, you've got to have a. Oh, yeah. Well, get it out. Is that all of them? That's a tough way to get so slow. Yeah.
46 divided by 394. You see where I got that? Okay. I have to do this with math. The first option is fractions. So you just have to take math, enter, and simplify.
Okay, anyway. Listen, you guys, question 4. What's the chance you choose somebody that's a girl given that they don't walk? That means they either, what? If they don't walk, then they take a bus or a private car. So these both have to form your denominator. You guys hear that? What's the chance you choose a female given that they don't walk home? So that means they either take a car or they ride the bus. So there's 651 people that do that. And then of the group that ride a bus or take a car, how many of them are girls? These people are girls. That's three, yeah, what was it, 339, thank you. And let's see, does that simplify? Let's see. 339 divided by 651. It actually does. 113 out of 217.
What about you recommending getting a calculator ready?
Thank you guys. Question 5 and question 6. These are interesting questions.
Yes.
Okay? What is the probability that Melissa rides the bus home? Okay? You guys, we have to set up a conditional probability statement. Now, which one is given? Is it given that she's going to ride a bus, or is it given that it's a she? How do we know it's a she? Her name is Melissa. So you guys need to understand how to set this up. Okay? It's a girl's name. It's a girl's name. Would this be correct? You guys tell me yes or no.
No, it's not.
Is that correct?
No.
That's backwards, right? We're trying to figure out what's the probability that she'll ride the bus if she's a female. So this is backwards. So what's the probability that Melissa will ride the bus knowing that she's a female?
So it's a bus. 154 over 403.
So of the girls, what's the probability you'll choose one that'll ride a bus? 154 out of 403. You guys see how that works? Now you have to read question 6 carefully. Jordan walks to school. What do we now know has to happen? We know that Jordan walks to school. That's our condition. Okay? What is the probability that Jordan is a male? So what's the probability that it's a male given that this person walks? We know that Jordan walks to school, so that's the condition.
Walk to school.
So, how many people walk to school?
82 males out of 394.
How many people walk to school?
146.
146.
Dude, only
Of them, there are 82 males.
Okay.
And then you'd simplify that.
Yeah, simplify that.
This is our homework.
After school job, that is a male, so it would be.
Okay. Let's see if we can speed this up. I'd like to get to some of the problems on the back.
Yeah.
Now you guys, this Venn diagram is set up slightly different in terms of the numbers. These are all percentages, 21%, 27%, 33%, 19%. If that bothers you, which some students it does, you can just consider that the whole sample space is 100 people and say, okay, out of those 100 people, 19 of them did that, 33 of them did that, 27 of them are here, and 21 of them. Then you can just make them into normal numbers. There's no difference. Okay? You can use one or the other. But I'm just going to leave it out as. These are percentages now.
It's easier to do math.
No, just put it back.
It'll be exactly the same.
So if the first
It's exactly the
after
same.
school job that is a male, so you circle the circle of the after school job and then the one in the middle. Yeah.
What's the condition on question 7?
After school job.
The condition is they have to be male. So here is what you're choosing from. So it'd be 20. What's the sum here? Well, here's 27, but together,
Maybe 48.
so it's out of 0.48. And of those 0.48 or the 48%, what percentage
47.
are male? What percentage? So the question is, they have an after-school job if they're male. So Of these males, how many of them have an after-school job? 0.27. Or you could just do 27 out of 48 and not use the decimals. It would be the same.
So they have no after-school job, so it's like 0.
Now you guys listen carefully to what I just said. It was a little while ago. You leave them as fractions if you're dealing with normal integer numbers. We're dealing with percentages here, so these also need to be given in percentages. So what is this percentage? You have to calculate it all the way down to a percentage. So 0.27 divided by 0.48. So it's 56.25% chance that if somebody has an after-school job, or if somebody is male, then they have an after-school job. So 56.25%.
Wait, why do we have to do that?
It starts out as percentages, so you end up as a percentage, because that's how all of these start out.
You always get it the same form as you stop.
Question 7. Sorry. 8. The condition is no after-school job. Now, a lot of students have had trouble figuring out the sample space. No after-school job. That is these people, but that's not all. These guys don't have an after-school job either. So how many people total have no after-school job?
30, 39, 40.
That's 40, right? So that's divided by 0.40. That's how many people don't have an after-school job. Now, of those that don't have an after-school job, how many of them are guys? 0.2. What does it say? Oh, female. We want females.
Well, actually, we don't. Yeah, we do, because all of the males in that Venn diagram are in the male circle. So we know that.
Somebody said it back here. It's 0.19. These are males that have after. These are females that have no after-school job out there. So and please don't leave those as fractions. Put them as a percentage because all of these started out as percentages.
You multiply it or you divide it, right?
Divide. So I'll give you a moment here to go through number 10, then we'll talk about 11 and 12.
What'd you guys get for, we got 56.2% for 7. What'd we get for 8?
47.5.
You got 47 and a half? What about over 8, 47? Same. What'd we get? Did anybody get 9?
I'm on it now. I got.
You got 43.7? 43.75? Anybody else get that? You got that? 43 point.
The fraction is 19 out of 40. Not sure.
43.75%.
Okay, now for number 10.
Number 10, you guys, the condition is they have to have an after-school job. So that's this circle. These people have the after-school job. Oh, you can't even see it. I'll put them in a salad. So this condition is they have to have an after-school job. So 2733.
Wait, let's finish 8. Let's do 8. Let's figure this out.
We just did 8. 19 out of 40.
Yeah, we have to put a percentage.
What was the percentage then on 8? 47.5%. Question 9 is 43.75. So back here to 10. The condition is they have to have an after-school job. So that's out of, so 0.27 and 0.33 makes what? Come on now, simple addition. 0.27, 0.33.
60.
So that's 0.6. I'm glad one of you in here can do simple addition.
No, you probably use the calculator.
Come on, people.
BS.
Simple, those are double digits, and 3 and 7 make 10. 3 and 3 make 6.
So of these people that have a after-school job, how many of them are guys? This section right here. 0.27. Of the people that have an after-school job, 27% of them are males. So 0.27 divided by 0.6.
0.45. 0.45.
Because if you choose all of the males, you're choosing some that don't have an after-school job, and the condition says they have to have an after-school job. It's how many males that also have an after-school job.
Over all the people that have that.
Yeah. So what is that? 0.27 over 0.6? Come on now. 0.45? So that's 45%? Now you guys, question 11 is really easy. All it does is ask you to, is the probability of having an after-school job given you are male the same as the probability of being male given that you have an after-school job? Use the probabilities in questions 7 and 10 to justify your answer. Are they the same in questions 7 and 10? Easy question.
Like taco chimes?
Yeah, don't you guys go there? A student works at McTaco Chimes. What is the probability the student is female? Now, you guys, this is a conditional probability. What do we know about this student?
Female.
Do we know they're female?
This says female.
We know they have an after-school job, so that's the condition. The condition is the probability that they're going to be female given that they have a job after school.
Are you sure we're going to assume it's after school?
That is a good question.
Maybe it's during their lunch.
It is not,
How do you know?
because I know. I know everything.
Mr. Speedo?
I'm Mr. Speedo.
Do they know you?
Speedo's not true.
It's Captain Speedo.
So, how many people have an after-school job? We just did that one in question 10. How many people have an after-school job? 0.6 or 60%.
Okay. So Speedo, what you give Mr. Speedo, someone's here for you.
Think cat.
Sorry. Well, Mr. Speedo, you
I
just
think
told me.
Captain Speedo makes
So we gotta be careful on this one.
It's going to be 0.19 for female, because that's the probability.
Yeah, what am I doing?
0.33. You got mine. It's 0.33.
We have to assume that the after-school job that 0.3 is female.
We have an argument going on.
Isn't 0.32 the female?
No, you should subtract the 0.33.
Because I'm saying after-school jobs, and 0.27 is the one for males with after-school jobs.
Yeah,
So that's why 33 has to be.
how many males are there?
Finishing this up here, they have to be female. These are the males that have jobs. We don't count them, so it's 0.33 out of 0.6. Now, as a percentage, 0.33 out of 0.6. Come on, what do we got? What do we got? What do we got? What do we got? 55%. Okay, turn it over.
Can we just go with number 9, because that's very confusing.
Yeah, I'm so confused on that.
Like, how can someone be left-handed? Like, it doesn't say male or female.
Okay, number 9 is just a review question from the last assignment.
But it doesn't make any sense.
Okay, I've asked you on number 9 to make a tree diagram. A tree diagram has this, and then it has this. It's very important that you decide correctly what goes on that first branch of it. Read through the results. of all of the respondents, 17% are male.
So we'll do,
Of the male respondents, 33 are left-handed. You guys listen carefully. That second statement tells you what the branches ought to be. Of the male respondents, 33% are left-handed.
Male, female, and the left.
So male, female have to come first.
So male.
And then of those male or female, we decide how many are left-handed or right-handed. So we have male, female.
Male is 0.7, female is 0.8.
0.17.
Yeah.
Yep. And then female have to be
0.83.
0.83. Now, of the male respondent, that means on the male branch, of the male respondent, we have left-handed or right-handed. Same with the female, left-handed or right-handed. Does that make sense to us? Were you listening to this? I was trying to help you with that. There you go.
I just didn't understand how one could be both left-handed.
The following is a different option. Chelsea Rivera,